Hi, I'm Dr. Kit Weathers, and it's time for the Root Tip of the Week. But before we get started, as usual, we're going to start with the magic trick of the week. This week's magic trick is very, very simple, easy to do, and I know you're going to like it. I'm going to show you how the trick is done with an ordinary key, and I've got a reason for this, but most of the time you'll probably want to borrow somebody's finger ring, and the trick operates exactly the same. So let me give you a close-up look now, and let's see if we can show you this key in close-up detail. So today's trick involves a key and a rubber band. I want you to watch very carefully and see if you can see that key slowly begin to move. It begins to crawl slowly up the rubber band, defying the laws of gravity as it gets closer and closer to my other hand. To learn the secret to this and other magic tricks in this series, go to EndoRootCamp.com. Well, I hope you enjoyed our little trick with the key and the rubber band. The example that we're going to show you is how this exact same phenomenon, snapping little rubber bands, which in this case are going to be Sharpie's fibers, cause a tooth to come out of the socket. And we're going to talk a little bit more about this. We mentioned the physics forceps a couple of months ago, but I've since had a lot more experience with them, and I think that you're going to find out that this is really almost a magical process. Now, the title of this presentation is the 1-minute tooth extraction. The people that make the physics forceps want me to tell you that a lot of times it doesn't happen in 1 minute. Sometimes it can take as long as 2 or maybe, oh my God, even 3 minutes to get a tooth out. So don't get in a big hurry. And even if you're putting pressure on a tooth for as little as 30 seconds to a minute, it's going to seem a lot longer. So I want you to keep that in mind. Now, very little has changed in all of the years on how teeth are extracted. Traditional extraction forceps can actually be compared to a pair of pliers. And a pair of pliers, if you were to try to remove a nail from a plank, you would find that you would have to twist and turn, wiggle back and forth, and finally it would tear free. And you'd have the same results if you took a standard pair of pliers or a standard forceps and tried to take a bottle cap off. You'd probably tear it, maybe even break a little piece of it. But the physics forceps uses a lever, a class 1 lever action, to gently move the tooth just a few millimeters from the socket. And this is the physics forceps. You can see the beak is attached to one side of the lid, and the other side bumper allows you to torque and gradually pop loose that cap. Same thing happens in the mouth. Now there's 5 steps involved in extracting the tooth. First thing you want to do is take a periosseal elevator and just free the tissue around the tooth. Then you want to set the beak of the forceps as far as you can on the lingual, and then set the bumper and gradually apply wrist pressure. You don't squeeze the forceps, you just try to torque it a little bit, and just by using wrist action alone, you begin to pull until finally the tooth pops free for 2 or 3 millimeters, and then you can reach up and either extract it with your fingers or with a rongier or something else, and the tooth will roll out of the socket. The whole key is to put pressure on until the Sharpie's fibers break loose and allow you then to extract the tooth. This forceps that we just showed you is not for extracting and taking the tooth out completely. It's simply to break it loose. Now, if you're trying to take out a multi-rooted tooth, you know that most of the time you'll have to section the tooth. The problem is most people section the tooth and then try to extract the roots. That's exactly backwards. But with the physics forceps, you can use the forceps to break the tooth loose a little bit and then section it. The other problem and the other mistake that most people make is when you start to extract or to section a tooth, many people try to go exactly perpendicular to the top of the tooth. If you do that, in this example here, you'll see that most of the time you're going to be a little off. A perpendicular slice into a lower molar will almost always wind up in the mesial root, and that's because the distal root is at an angle. So what you need to do is angle your cut towards the distal just enough to where you can make a clean separation. Problem is you don't always know where that separation point is, but if you use The physics forceps, the red line here, represents what most people do, and that's to go perpendicular to the occlusal surface of the tooth. That will frequently get you involved in the mesial root. The blue line is at a slight angle, and that's what you want to do. Now let me show you this in the mouth. The beauty of the physics forceps, once you pop the tooth loose, and we'll show you that in just a minute, you can now take an instrument to raise the tooth up in the socket a little bit, and you can make your section nice and perfect because now you can see exactly where those roots are. And by slightly elevating the tooth before you section it, you will wind up with a very clean alveolus. You're not going to be cutting into the bone and slicing the tissue around this area as you frequently used to do with the old style of sectioning teeth. Another trick you're going to want to use with the physics forceps is you want to take a flame-shaped diamond and go 2 or 3 millimeters below the crest of the bone, cutting into the root of the tooth, not into the bone itself, and that will give you something to place the beak of the physics forceps down into that little slot that you've made, and as it rotates back and puts a little pressure on it, it will begin to pop the tooth loose and it'll come straight up out of the socket. It is a wrist action rotational motion, and again, it could take 2 to 3 minutes for that to happen, but my thumb is the bumper, my fingers are is the beak, and it pops the tooth loose. Now, we've all had to extract teeth that are rotten right down to or below the gum line, and you know how much difficulty this can bring you. But by using the flame-shaped burr or diamond, as we talked about, cutting that little slot, you can easily seat the beak of the forceps into that little slot, and with just a pressure on there, gentle pressure, held for a minute or maybe even 2 minutes, you'll find that it will suddenly pop loose and roll right out of the socket. You won't be digging around looking for broken root tips. Here's another example of the same thing. This is another tooth. The little slot is made. Seat the beak up into that slot, a little rotational action, and it will pop right loose and slide right out of the socket. You can actually remove these teeth with your fingers most of the time. When I first saw the physics forceps, I wanted to hate it because it looked to me like it would probably fracture the alveolus, but the secret is wrist action slowly breaks that tooth loose from the fibers, and then you take it out, either section it, or you can, in straight canals or straight teeth, you can just roll it right out with a Rongier's or something else. Now, if you want to learn more about it, go to physicsforceps.com, or you can call and order this at 877-987-2284. I know this sounded like a commercial for the physics forceps, but I tell you, I love it. As a matter of fact, I shared it with a friend of mine, and he didn't give it back, and I had to order a whole nother set because you can't live without these. Once you try them, you'll never want to extract a tooth again without having the physics forceps. Anyway, that's it for this week. I'm Dr. Kit Weathers. I will see you next week. Well, that's it for another Root Tip of the Week. I'm Dr. Kit Weathers, inviting you to join me at our very next Root Camp. So long for now.